This mini lecture for Module 9 is going over the significance of main effects in interactions. Here's an example of a factorial Anova where we have factor A, which is related to handedness, and factor B, which is related to gender. And here we have men and women. And we have a dependent variable, which here is lifespan. In this case, all effects were significant plus the interaction. So let's walk through this. If we look just at factor A, we're looking at handedness. So we don't care if the individual belongs to the category of women or men. We only care about left or right. So when we look at factor A, we figure out the means for each of these that I've represented by this bar. And you can see that for left-handed people, the dependent variable has a lower value than for right-handed people, and this factor was significant. Now, if we look at factor B, we're interested just in the categories here of women and men, and we don't care about handedness at all. So in this case, the blue line represents the mean value of the dependent variable for men, and the red line represents the mean value of the dependent variable for women. We can see that there's a difference in these values, therefore this factor is also significant. Of course, we're just looking at the graphic here. We would do statistical analyses on this as well. And then when we look at the interaction, that says, is there a change in the relationship of A and B when you look at them together? And what you can see here is that the lines cross, and so for left-handed individuals, women have a lower value for the dependent variable than for men, but if you're looking at right-handed individuals, the women have a higher value than men, and that represents the significant interaction. Now, what I've shown here is two different graphs, so one on the top, one on the bottom. They represent the exact same data. The top one just looks at them in terms of using symbols to represent the means and then a line to show the relationship, and then the one on the bottom is using bars here to represent the mean value at the top of the bar. But they're showing the same data. This and the next 4 slides are all going to be like this. So when we look at this case, again for factor A, we're only interested in handedness, so we're only looking at the main effect of factor A. So we don't care in this case if the subject is male or female. So I've put the lines here to represent the means across male and female for left-handedness and across male and female for right-handedness, because again, we're only interested in handedness. You can see there's no difference in these mean values if you look at the top panel or you look at the bottom panel, because again, the data is the same. I'm just showing it to you in 2 different ways. So it's not significant. When we look at factor B, now we're looking at males and females regardless of handedness. So I'm showing you lines here, and these are dashed lines because, of course, in this case, they're overlapping each other. So we see that there's no effect of male or female on our dependent variable. So again, it is not significant. And because these patterns don't change for factor B, depending on the value of factor A, the interaction is also not significant. So there are no significant effects here at all. And you can also see that because all the values are the same for the dependent variable across the treatments. Now in this case, and again remember that the top graph and the bottom graph are showing the same trends and relationships. Here when we look at factor A, we're looking again only in handedness. We don't care if the subjects are male or female. So I'm showing you the mean values by these bars. So this is the mean of male and females who are left-handed and the mean of males and females that are right-handed. And you see there's a higher value for the dependent variable for right-handed individuals. So therefore that factor is significant. Now when we look at factor B, which is male or female, now we don't care about handedness. It doesn't matter what handedness they are. We're only looking to compare males and females within factor B. So here the blue line is approximating the mean value for males, and the red line is approximating the mean value for females. You can see that there's separation in these lines. So again, in this case, it's significant. And when we look at the interaction, that's when we're asking, does the influence of factor B change depending on our value for factor A. And again, in this case, it is not significant, represented on the top panel by the fact that those lines are parallel. And in the bottom graph, you can tell that it's not significant because the relative spacing between males and females, if they're left-handed or right-handed, follows the same pattern, right? So females always have a larger value, and the magnitude of that is consistent between those two things. So the main effect of factor A is significant, the main effect of factor B is significant, and there's no significant interaction. Now in this case, we still have factor A as handedness and factor B is gender, looking at males and females. When we look at factor A in this case, it is not significant. And when I show you the means for only factor A, so we're only interested in handedness, so we're pooling across males and females for left-handed, pooling across males and females for right-handed, you see that there's no difference in these values. Therefore, factor A is not significant. When we look at factor B, now we're comparing males and females, regardless of if they're left-handed or right-handed. In this case, those mean values are identical. In the top panel, you can see that although they cross, the magnitudes of males and females, because they have one high value, one low value, end up being the same. Also, because they cross, we see that there is a significant interaction in this case. And our last example here is still looking at the same premise with handedness and gender. One important thing to point out with any of this, when we look at our factor A, when we're only looking along our x-axis here, regardless of the other groupings. So in this case we have handedness, but if we had 3 different groups that fell under factor A, we're still going to do the same thing. When I show you the means of left or right, and if you maybe had ambidextrous or another grouping like that, it still doesn't matter if you have just 2 groups like males and females, you're still going to average across those, okay, to look at the effect of factor A. So we can see that although for left-handed individuals we have these extreme values, right? Females have very high values, males have very low values. Then when we average across that, the mean for left-handed individuals is very similar to the mean for right-handed individuals, where we have less variation. That's why we say factor A is not significant. When we look at factor B, now we're looking only to compare males and females. And you can see in the top panel that the females always have higher values than the males, right? And you can also see in the bars that on the lower panel that the females always have higher values than the males. So once we superimpose what the mean values are there, we can see that there is a significant effect of factor B, which is gender. And when we look at the interaction here, it is significant. While these lines in the top panel do not cross, they would cross if there was if they kept going, right? Those lines are not parallel. So we do see a significant interaction here. Also, by looking at the bottom panel, you can sort of draw lines on those and the tops to mimic what you see in the top panel. But the other thing you can see is that for left-handed individuals, the magnitude of that variation between the means is very large, but for right-handed individuals, it's very small. And because there's a difference in those magnitudes, that indicates that there's a significant interaction between those groups.